Now we're back at the very last lesson of Chapter 3, Exploring and Expressing the Law. So this lesson is going to be including lots of problems that's going to be including finding patterns and the ability to think abstractly. And it's going to be using lots of the concepts that we've learned in this chapter and before. So be on the lookout, see if you can use any skills that you've learned, and let's get on with it. So yes, after you finish chapter 3, you'll be moving on to chapter 4. And in chapter 4, you're learning all about geometry. Okay, so the learning goals for today is being able to use algebraic expressions to express the changing laws of numbers and figures. And 2, further cultivate the student's thinking ability and application awareness, such as observation, analysis, abstraction, and generalization. So now we have the introduction to this class. First, stretch out your left hand, just like this hand in this picture, and do the following activity. Starting from the thumb, so like this, count the numbers 1, 2, 3, 4, 5, like the hand shown in this picture. And now we're asking if you go 1, 2, 3, 4, 5, and then go back without repeating this pinky and this thumb, how will you know which finger will the number 20 fall on? Just something to think about. How can you know that? Also, can you quickly tell which finger the number 200 falls on? And how about 2000? So now we're going to get into our class, and the first section is the law and the change of numbers. So let's first look at this here. It's actually a calendar. Please observe carefully the calendar and answer the following questions. So really, this calendar is really just a series of numbers and patterns, and we'll be uncovering those patterns. So let's go ahead and see the questions. 1. Please find the relationship between the three adjacent numbers on the same horizontal line. And 2. Please find the relationship between three adjacent numbers on the vertical line. 3. Please find the relationship between three adjacent numbers on the upper left and lower right diagonal lines. And 4. Please find the relationship between three adjacent numbers on the lower left and upper right line. Okay, so let's first do one of them. We're going to do three adjacent numbers on the horizontal line. So we're first selecting a random set, which is 4, 5, and 6. Now I'm asking, what pattern can you find in this series of three numbers? What relationship or how do you get from one number to the next? The first obvious answer you might come up with is add 1. That's also a pattern, and that is the pattern to get from 1 to the next one. So let's go to another set, but in the same formation. So 19, 20, and 21. This is a little bit off, but let's just say it's 19, 20, 21. The same pattern still applies, so that means what we found, the observation we had, was correct. It's also 19 plus 1 is equal to 20, and 20 plus 1 is equal to 21. Now let's try another one. We have 3, 10, 17. What pattern can you observe from these three numbers? To get from one number to the next, you will see that you need to add a 7. 3, the difference between 3 and 10. So 3 and 10 has a difference of 7, and 10 and 17 has a difference of 7 as well. Now let's look at another random set. 6, 13, 20. You add a 7, you get from 6 to 13. You add another 7, you get from 13 to 20. Still applies. Another one, 19, 25, 31. Well, what is the pattern to get from one number to the next? So these numbers, well, let's see. Well, we can observe that 25 is 19 plus 6, and 31 is also 25 plus 6. So it seems like the difference of the pattern here is plus 6. Let's try another random set. 7, 13, 19. Let's try to add a 6 to 7. That's 13. Add another, that's 19. And our last one, 8, 16, 24. What's the pattern here? Well, it should come to you that they're all multiples of 8, and not just multiples of 8, but adjacent multiples of 8. So you can see that the difference between them is going to be 8, and that's our pattern. Another random set. So now let's try something else. First, we have a random set of 9 numbers. 10, 11, 12, 17, 18, 19, and 24, 25, 26. Now we're going to circle or box up the middle number, which is 18. It's right in the center. Here's come the question. What is the relationship between the sum of the 9 numbers in the green box, so all of these numbers including 18, and the number in the middle of the yellow box? It says yellow, but it's actually orange. So what is going to be the sum of everything? 2, 18. And the pattern we found should also apply to 5, 6, 7, 12, 13, 14, 19, 20, 21. Let's take a guess. The sum of the 9 numbers in the green box is equal to 9 times the number in the middle. Expressed algebraically, this number here, of course, is equal to a minus 1. This number here is equal to a plus 1, and remember this middle number is a. And this is also just a model of a random set of 9 numbers from the calendar. So the middle number is the unknown value, a. This is going to always be a minus 1. And this is using the patterns we've learned before that we made as observations. This is a minus 1. This is a plus 1, a minus 7, 8 minus 8, a minus 8, a minus 6, a plus 7, a plus 6, a plus 8. So then all of these added up together would be 9a. Remember, you should remember how to remove brackets. You should remember how to combine like terms. So the conclusion is the sum of 9 numbers in the green box is equal to 9 times the number in the middle. So all of these numbers added up together is equal to 9a. Remember, 9a is just another way to express 9 times a, and a is the number in the middle. This is going to be having some sort of activity. And the activity is, what pattern did you find among the numbers in this cross shape? This cross shape is any shape that's just kind of like a plus sign, and as you can see, this is that pattern, and it's asking for how did you verify. Okay, so take a moment to look at this. Well, the pattern is that could be a random cross shape. The pattern is the sum of the 5 numbers in the cross is equal to 5 times the middle number. You might want to pause and then right now try to verify it, which is adding up all of these 5 numbers and then multiplying the middle number, which in this case is 17, with 5, and then try to see if those values are the same. Okay, next one. We have a H pattern. What is the patterns of the number in this shape? How did you verify? So again, take a moment to look at this. Again, we take any random pattern that's in the H form, and the pattern is that the sum of the 7 numbers in the H shape is equal to 7 times the middle number. Are you starting to catch a pattern? Why is this happening? So finally, can you design other shapes of number boxes that contains the number patterns? Can you yourself design any? Well, for me, I just look, well, the others, it kind of seemed like they were symmetrical in some way. I'm just going to try to play around with it, make cross signs. And this, for me, I made the X shape. So here are the general steps to explore the pattern. So as a conclusion all of that, here are the general steps to explore the patterns of specific problems. So we have a problem. You have to find that what is causing this problem? What is that gritty nitty spot where once you figure that out, most of the other things that you need to figure out, it will be easy to find out. So you're going to have and find that problem yourself. Then you're going to observe and compare. Compare one term with another. Compare how these are the same and how they're different, and observe them. Then we're going to guess the pattern, or really not guess, really just kind of have a hypothesis. Like if, because these are different and similar, we can have the hypothesis that this pattern might match into that. We're going to try to express the pattern by taking a random case and then just trying to fit it together. Then we're going to verify the pattern. So if it's correct, we're going to get the conclusion and answer that problem. If incorrect, we're going to rediscover pattern, go all the way back, observe and compare. This table right here is something really, really important. So you might want to quickly make a small model of it or take notes of it in some other way that's going to help you remember it later in your notepad. So pause the video and do that. This is super important. Did you make sure you write it down on that notepad? Because if you didn't, well, you're gonna have some trouble finding it in some other problems we have. Now, here's a problem. So we have these expressions over here. 1 plus 2 plus 3 all the way up to 10 is equal to this expression. 1 plus 2 plus 3 all the way up to 31 is this expression. And 1 plus 2 plus 3 all the way up to 100 is this problem. Now we're being asked 1 plus 2 plus 3 all the way up to an unknown variable n. How will we describe it in this expression form? We don't need a complete answer, we just need that section. Okay, let's first go back to what we have over here. So we have a problem, and then we're going to observe and compare. Okay, so we're gonna go back and find the problem. So let's look at all of these and try to find the similarities and differences. Well, they're all the same really pattern, it's just that they add up to different numbers. So 1 plus 2 plus 3, it's always adding up like that, except the last number that's being added is different. In this case, it's 10, 31, and 100. Is there anything else that changes? Really not, because that's really the only thing that's changing. And it seems like over here, in the second section right here, there's also changes. Well, the denominator of these fractions are always 2, and it seems like it's always 1 plus the last number being added times the last number being added. Now I'm going to ask you, what is the last number being added in this fourth equation? Right, the problem already told you. The last number in this equation is n. Remember, n is a number. It's just a number, but being expressed in a different way. So this last term is n. Then that gives us our answer. I mean, if the only thing that changes is this n, and we don't need to solve anything to one individual number in the end, it'll be easy to deal with, because first of all, we know that the denominator has to be a 2. Then it will be n times, and we know that the numerator is going to be, in parentheses, 1 plus the last number being added, in this case n, so that's 1 plus n, being multiplied by the last number being added, in this case is also n. So that would be n times the sum of 1 and n divided by 2. Now let's get to some problems. Example 1. 1, negative 1 half, 1 third, negative 1 fourth, 1 fifth, negative 1 sixth. Goes down in a pattern as the following shows. And you see this pyramid-like figure here, made up of negative and positive fractions. So now we're being asked, please find the 10th number on the 20th row. Let's look at this together. What can you notice about the negative signs? Yes, the negative signs only appear when the denominator is an even number. So, for that case, we can first temporarily ignore these signs. It does so here in this analysis. The positive and negative signs in the question can be temporarily ignored because when you find the number of if the denominator is even, it will be negative, and if the denominator is odd, it would be positive. Okay, now we're taking it to the next step. These numbers have one number in the first row and two numbers in the second row. So there is a total of 210 numbers in the first 20th rows. That is, the last number in the 20th row is negative 1 over 210. So let me explain that section a bit. As you can see here, in the first row, there is one number, second row 2, third row 3, fourth row 4 numbers, fifth row 5 numbers, and goes so on. So what this is saying over here is that in the first 20th rows, not just the 20th row, in all the numbers in front of it, there will be 210 numbers. So the last number will be negative 1 over 210 because 210 is even and is on the denominator. And each even denominator will be a negative fraction. So the last number in the 20th row is negative 1 over 210. And then, because of that, the 10th number in the 20th row can be obtained by going back 10 fractions. So we'll get negative 1 over 200. Use algebraic expression to express the pattern of the value variation. Numbers are integers. Consider whether they're patterns in the sum, difference, product, quotient, sign, etc. Of two adjacent numbers, it can also be the patterns of being odd, even, square, etc. 2. Numbers are fractions. You can observe the changing patterns of the numerator and denominator, and then the relationship between them. And 3. If it is an equation or table that represents the law of value variation, you can write each question correspondingly, and then compare the relationship between each row and the column of the numbers to find the pattern. So drawing the table and then comparing the column of the numbers and the rows. Now let's look at the patterns in splicing of graphics. Example 2. Observe the pictures below. They are arranged according to a certain rule. According to this rule, the 16th figure will have a total of blank stars. So I want you to look at this for a moment. What is a pattern we can see among these stars? So it's asking for how many stars will the 16th figure have? Well, to do that, let's first count all of the stars in each graphic. The first one is 4. First one is 4. Second one is, we add 3 more, 7. And then after that, we add 3 more, 10. After that, we add 3 more, which is 13, and so on. So for the graphics, making a table is extremely helpful. How we can do this is make a table, right? Okay. And then how it's going to work is there's a table right there. And on the top, it'll be what graphic, and at the bottom, it will be how much stars. So number 1 has 4, number 2 has 7, number 3 has 10, number 4 has 13, and I'll go so on. So let me ask you, what will the 5th graphic have? How much stars will it be? It'll be 5, and then you add 3, which is going to give us 16. So say this top number is equal to n. Then what will this bottom number be? We want to figure out the pattern. So 1 is 4, 2 is 7, 3 is 10, and we want to get to the nth graphic. To do that, the pattern will be, we start with 1, right? We start with 1, plus, and since it keeps adding 3, 1 plus 3n. So that would be 1 plus 3n. It's 1 plus 3n because the 3n is all of these. So this is 1 and 3. And it's 3, 3, 3, 3, 3. It's keep adding from that 1. And it's n times. So it's 3n. But we still have to memorize that there's this 1 over here that we still have to do. So that's 1 plus 3n. This n right here is equal to 16. It's asking for the when n is equal to 16, the 16th figure, or the 16th graphic. So 1 plus 3 times 16, that is going to give us 49. So again, once we look at this analysis, it's the same solution. Graphic 1 has 4 stars, graphic number 2 has 7 stars, graphic number 10 has 10 stars. Sorry, graphic 3 has 10 stars, graphic 4 has 13. So from this, we can know that the nth graphic will have a total of 3n plus 1 stars. So the 16th graphic will have 3 times 16 plus 1 star. So the answer is 49. Practice. Observe the following figures. The number of triangles in the nth figure will be blank. Using how we did a problem from last time, I want you to try to figure this by yourself before unpausing and hearing the answers. What answer did you get? Let's do this together for a moment. Again, we'll create the table there, and we'll put in the value. So on the top, it will be figure number, and then at the bottom, it will be how much triangles. So figure number 1, we have 1, 2, 3, 4 triangles. Figure number 2, we have 1, 2, 3, 4, 5, 6, 7, 8 triangles. Figure number 3, we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 triangles. So to the nth figure, it is very clear that it's 4n. So the answer is D. Here's a conclusion. The characteristic of the law inquiry problem is that the conclusion of the problem is not directly given, but through the series of inquiry activities such as observation, analysis, induction, generalization, calculation, judgment of the problem, the conclusion of the problem can be obtained. This kind of question has a unique regularity and exploratory nature. So here's number 3. Layer the cubes with the length of one edge as 1. So the value of one edge is from here to here, 1. And we're trying to find how many cubes are going to be needed for figure 5 and 6. So there are the cubes with the length of an edge as 1, showing the figure how many cubes are going to be needed for the figures 5 and 6. Again, what do we have? Tables. So for this table, I'll draw it out. On the top, it will be the figure number. At the bottom will be how much cubes. 1 is 1. 2 is 4. Remember, this over here, there's still a cube hiding right there. It's just beneath all of these other cubes. It's 2 and 4. 3 is 3. Figured it out. 1, 2, 3, 4, 5, 6, 7, and add 2 more, that's 9. And then what pattern can we see here? So to the nth, what pattern can we see? Of course, for this, it's just figures 5 and 6, so you could draw it out, but there's an easier way to do it. Do you still remember what are exponents? You are going to try to memorize all your exponents and your exponent facts so that you, for example, for the square, so that you can find out patterns easier. It'll make your calculations easier. Okay, now let me ask you, what is 1 squared? 1, okay? What's 2 squared? 4. What's 3 squared? 9. So what would the nth figure have? It'll have n squared. So if we're trying to find the cubes for figures 5 and 6, we just square them. So figure number 5 will need 25 cubes as an answer. So answer. Figure number 5, of course you'll need better sentences than this when you're actually answering a question, but just for the sake of time, I'm doing it like this. So figure number 5 will need 25 cubes. And then figure number 6 will need 36 cubes. That is the answer. Another practice. As shown in the figure, the floor is laid with gray and white square tiles. There are blank pieces of white tiles in the nth figure. Remember, this is only asking for pieces of white tiles. And we're being asked how much white tiles in the nth figure. Okay, what do we have? Table. So we draw a table. The top will be the figure number, the bottom will be pieces of white tiles. So figure number 1, how much white tiles are there? 1, 2, 3, 4, 5. Number 2, how much? 1, 2, 3, 4, 5. And then we have 3 more, that's 8. 3, we have 8, we add 3 more, 11. So, what pattern can we sense right here? What will the fourth figure have? Add 3, add another 3, 14. Now that we can already figure out what number 4 is, we can probably figure out what number n is, right? So for number n, okay, there are different ways to describe this. How can we describe it? What is the difference? It's plus 3, plus 3, plus 3, and this is exactly plus 5. But for the plus 5 right here, we can think of it as plus 2 and then plus 3. Do you see that? Plus 2 and then plus 3. And there are going to be 3, so there's going to be n times of adding 3's, including this one right here. So that will be 2 plus 3n. The answer is 2 plus 3n. It's going to be 2 plus 3n pieces of white tiles in the nth figure. Let me erase these. It's 2 plus 3n, or 3n plus 2. So observe that the number of the white tiles in the first figure is 1 plus 3 plus 1 equals 5. Well, this is a different solution. So 1 plus 3 plus 1 equals 5. The number of white tiles in the second figure is 2 plus 4 plus 2. The number of white tiles in the third figure is 3 plus 5 plus 3. So then the number of white tiles in the nth figure would be n plus 2 plus n, which is 3n plus 2. This is also a very clever way to figure it out. This was kind of looking at it in columns. It will also work the same way in rows. So there's different ways. You don't just want to have one way. Always know that there's many ways to do one problem. Next problem. Observe the following equations. 3 squared minus 1 squared is equal to 4 times 2. 4 squared minus 2 squared is equal to 4 times 3. 5 squared minus 3 squared is equal to 4 times 4. Now we're being asked, fill in the fourth equation. The nth equation will be blank. So what we need to do is write the nth equation, and we need to write down what will come next in this pattern. Well, over here there's 3, 4, 5. Then after 5, there's a 6. 6 squared minus, of course, 4 squared, because it's 1, 2, 3, will be equal to 4, that never seems to change, times, and then 4 times this other factor seems to be the number in between these being the numbers being squared. So 3 and 1, in between there's 2, 4 and 2, in between there's 3, 5 and 3, in between there's 4. So it seems like that would be 5. 6, 5, 4, 5 in the between 6 and 4. That's the fourth equation. The nth equation will be n plus 2 squared. So as you can see here, why is it n plus 2? Because this is first equation, this is second equation, and this is third equation. So it would always be n plus 2, the whole thing squared, minus n squared, it's 1, 2, 3, 1, 2, 3, 1, 2, 3, is equal to 4 times n plus 1. 2 is equal to 1 plus 1, 3 is equal to 2 plus 2, 4 is equal to 3 plus 3. That's the answer. This is a really simple kind of find the pattern, fill in the blank type of question, and it doesn't even have anything. It's already out there. You just had to fill in an equation and then write the nth equation. Now we have a class summary. We learned how to explore and express the patterns, the laws of things in a series, and that was split into the law and the change of numbers, and patterns and the splicing of figures, exploration, conjecture, verification, special, general, and here's what we learned. So the first skill is how to use algebraic expressions to demonstrate the variation of figures/values. So we were able to create algebraic expressions based on what was happening right there, and we practiced the ability of thinking and application awareness, such as observation, analysis, abstraction, and generalization. I hope you enjoyed this video. This is the very last lesson of chapter 3, and we'll see you again in chapter 4.